Thank you, Ann, for the introduction. Another bit of information. I worked for the oil industry for 40 years, so I'm here to pay for my sins. And fortunately, my last 10 years with Shell Oil, I was working on climate change technology, so they're not all that monolithic. We put a foot in the door when we can. So I'm representing two organizations, basically, the Cape Ann Climate Coalition and the HeatSmart Alliance. Next, you see a couple images. One is where we're giving a tour of a climate-friendly yard that's got not grass, but some plantings that are a lot better. That's not mechanical engineering stuff. Don't ask me. The next one is we're marching in the Horribles Parade in Gloucester. That's kind of fun in July. And on the right, we put in a tide gauge in Gloucester Harbor, indicating where we expect the rising sea level to be in the future. And that gets a lot of attention because the tourists go past there in the little boats when they're taking the harbor tour, and it's kind of a good display. Next. HeatSmart Alliance. Our mission is to do good stuff with heat pumps. We're all volunteers, educating, coaching, and collaborating, and we're just totally independent of any donations or other entanglements. And by the way, if you want to learn more about the HeatSmart Alliance, we've got some information on the table, and we've got one of the founders, Bob Zog, in the back, who will be able to chat with you whatever you want to know about HeatSmart Alliance. He knows more than I do. Next. Why heat pumps next? So home heating and cooling is a very important component of the overall emissions picture for greenhouse gases. On the left, you'll see in New England, residential use is about 30% of the total greenhouse gas emissions. And so of that residential use, heating and cooling is about 61%, and hot water is 17%. Sorry, I don't have these memorized, I've got to look at them. So about 80% of the home energy needs can be addressed by heat pumps. Next. So what's the path to decarbonization? It's not just heat pumps, there's other things we need. First is weatherize. You insulate, you weather seal, air sealing, and then when you've got your home more efficient in terms of heat loss, you can start electrifying. And when you electrify, you do heat pumps and other things. And the shifting to renewable energy can further reduce your greenhouse gas emissions, because if you just get from national grid, there's carbon in that. Showing on the panel there are some examples. There's solar panels, your EV, your water pump, your water heater, and heating and cooling. And then the possibility that mentioned here about renewable energy. Next. What is a heat pump? Well, it moves heat from a low temperature to a high temperature. You think of a water pump, it moves water uphill. A heat pump moves heat from low temperature to high temperature, same kind of deal. And it's a mechanical device. It uses refrigerants and all kind of fancy stuff inside. And you have examples of heat pumps in your house already. You've got refrigerators, you've got dehumidifiers, and air conditioner is a heat pump. In fact, a heat pump in your house is actually a reversible air conditioner. It can take the warm air from the inside to the outside in the summer, and in the winter it takes the colder air from outside and pumps it to the inside. So you can do that for heating and cooling. You can do water heating with a different device. There's possibilities for clothes drying and pool heating, but they're not as advanced or economically useful. But there's a big leverage possibility with this because of the way the thermodynamics work. 1 unit of electricity pumping heat into the house, it takes 2 units from outside and then puts 3 units into the house. So you get like a 3-to-1 multiplication. If you had like just regular baseboard heating with electric resistance heaters, that's a 1-to-1. You put 1 unit of energy in, you get 1 unit of heat out. With a heat pump, you get like 3. And it could be more with different types of heat pumps. And it also gives you heating and air conditioning, winter and summer. Next. As the mechanical engineer, I couldn't stop at that last one. I just have to point out some of the more detailed stuff. You've got 2 heat exchangers, coils. The one outdoors is taking the outdoor air and exchanging heat with the refrigerant. And then on the indoor, you've got another heat exchanger that's exchanging heat in there. And in the winter, as I said, you take your outdoor air and you actually evaporate the refrigerant there. And it goes inside, pumped inside, and then it condenses. And condenses, it releases heat into the inside. And then in the summer, you reverse it, and it runs just like an air conditioner. So what I said backwards. Next. So what are the benefits of heat pumps? They used to be mostly in the South a long time ago, and the technology has been advancing so that you can work in colder climates like New England. And so it gives you a substantial reduction of greenhouse gases because of that leverage, that 3-to-1 thing I talked about. Your energy cost, I'm going to let Brian talk about that. Because it's always changing. It depends what you pay for electricity. It depends what you pay for gas or propane or oil. And it depends what your projections are over the life of your system. If it's going to last 20 years, what's the price of electricity going to be in 2043? I don't know. But let's just say that in general principles, since natural gas is cheaper than oil or propane, you're more likely to save on operating cost if you're replacing oil or propane. Natural gas is a tougher competitor, and you're less likely to save compared to natural gas. But always compared to your electric baseboard, because there's multiplication factor, you always save compared to electric, by like a 3-to-1 factor. Other factors, kind of aside from the economics, it's safer. There's no combustion sources. There's no carbon monoxide. There's nothing going to explode. And year-round comfort, if you have a system that can sort of modulate, run at partial load instead of an on-off thing, you're going to be more comfortable because your temperature is more constant summer and winter. Next. How much emissions reduction? Well, this is an absolute comparison in terms of metric tons of greenhouse gas that you get per heating season. And you can see the most efficient one is the ground source heat pump. It's got the lowest emissions. This is based on National Grid's is it the current or the projected mix?
It's actually projected over the next 15 or 20 years.
So there's a case where we do know the future because there's a commitment by the utilities to meet the state mandates for reducing their carbon content. So we can project that over the next 20 years. Air source is a little less efficient, so it doesn't save. It has even higher emissions. Natural gas and propane and fuel oil, they just poop out all the carbon as CO2, so you're not going to change that. Baseboard heat is showing you that sort of 3-to-1 ratio. And noting that your emissions with any of these electricals, with a ground source or an air source or baseboard, those are assuming you do the National Grid thing. If you get your electricity from a 100% renewable, those emissions go to 0. What type of heat pump is right for your home? Here we get to the question. First of all, what's your existing distribution type? And I have to put the hydronics in quotes because you're going to hear this from suppliers maybe and people talking about it. It really means that you've got a hot water or steam system. That's what the hydronics means. And if you've got a unit in your basement or whatever to produce that hot water or steam, that's called a boiler. You can tell because it's got water or steam pipes coming out of it. Those water or steam pipes go to the baseboards where you have the typically pipes or steam radiators where you have typical steam. That's one type. The other thing you may already have is forced air system, and that's where you have a furnace. Furnace burns the fuel and makes hot air. The air goes through the ductwork distributed through the house, and it goes through supply vents and goes back to return vents. Here we go, heat pumps. The so-called ductless mini split. This is for your hydronic distribution. What can you do if you already have that? And basically that says most of the time you don't use the ducts. You put in these units, the single zone or multi-zone. It makes that refrigerant that flows to separate units that are located inside the house, in various rooms of the house. A wall unit, typically for the outdoor unit, single unit, single zone. If you have multi-zone, you have sort of a central supply of the refrigerant, and it's feeding multiple units that are distributed around the house, just piping the refrigerant around. So you can have cassettes in the ceiling, you can have a compact one, you can have a wall unit, you can have floor units. And note here on the right side, if you have that existing heating system that you're not removing, you can keep it as a backup. And the backup can be for extremely cold days, or in the event that your heat pump fails, as they occasionally do, you'll still have some heat from that. On the bottom, I noticed that I note there's a sort of oddball thing. You can have an air-to-water heat pump and then use your existing distribution system, but it's kind of a pain to do that. You got to worry about insulation and condensation and dripping, and not very common. So next slide. So for forced air distribution, where you already have the ducts, you can have a central air source heat pump that puts the refrigerant into your indoor furnace with a coil on top of it or associated with it. On the left side there, on the left-hand side to the right of the outdoor unit is an indoor air handler. That is a way to say that you've got your refrigerant coming into it rather than into your furnace. So that's complete electrification if you're not keeping your existing forced air system. On the right side is a ground source heat pump, and this maybe addresses one of the questions. Rather than going outside to get the air to exchange with that coil, you're actually pumping a loop of antifreeze solution around. It can go either down a well and back up, or it can go into some submerged horizontal tubing. And I know in Rockport, we can't do that horizontal thing because we've got too much ledge. And I don't know what it is here, but if you don't have a lot of soil, you can't do that. But you can at least put down a well and circulate the antifreeze system. And then that's kind of a different animal, because then all your stuff is inside. You've got a complete electrification where that unit sits inside the house, and it just takes the water from outside and does its trick. You might be able to use the existing ducting if it's suitable. It has to be insulated and sealed and properly sized, and if it's not, you're looking at some maybe expensive upgrades. Next. Okay, here's the detail on what ground source versus air source. On the ground source, in terms of the stuff that I hope Brian's going to talk about, there are some larger incentives for putting in the ground source. They are higher efficiency. As I mentioned, that multiplication factor is like 50 to 70% higher efficiency. So you get lower cost of operating with electricity, lower emissions. You don't have anything outdoors. There's nothing above ground. You can get a factory sealed heat pump. And nicely, your equipment is protected from the weather. And if anybody's located along the shore, you know that salt spray can do a job on your outside equipment.
Why is it 70% higher efficiency than air to an air source? To a point?
It's because you're taking your source of heat from which you're removing the heat to pump it into the house is a higher temperature. Whatever you come out of the ground, it might be 50 degrees, okay, and then you're pumping it up to inside 85, whatever.
So does that work the other way if you're trying to cool a place?
If you're trying to cool the place, you're exchanging it with your outdoor air. No, you're still exchanging it with the ground. In summer, it actually still helps you because you got 50 degree, or maybe it's a little warmer in the summer, but say 50 degrees water coming out of the ground, and in that case, you're using it to pull down your air from inside the house.
So it's a more constant temperature, 50 degrees
yeah.
in the winter, 50 degrees in the summer.
More or less constant from underground, and it turns out that that's better in both cases. And the higher efficiency is based on that. It's a thermodynamic thing. You can write an equation for it, and then everybody gets lost. So factory packaged, I mentioned, protected from the weather. Air source is a little more common now, especially, and it's lower first cost. It doesn't really disturb your landscaping. You can kind of put it close to the house. It's a fairly small outdoor space, and it gives you more options for the ductless systems. Next. Domestic hot water, you can use kind of a similar system that actually takes heat from a room where your water heater is sitting and pumps it into your water. And if you have a ground source system, it kind of does that built into the ground source. Next. So what's your action plan? Convert to a heat pump when? When do you do that? Well, if your equipment is aging, like over 15 years old, or your water heater is more than 10 years old, that's a good time because it's getting near end of life. So do plan ahead, don't wait for the failure. If you're adding AC to your home that doesn't have it, it's a good way to get heating and cooling. If you're planning an addition, you can meet 100% of what you're adding or go back and do 100% of the whole house. Next. How to get started, you get informed. There's some website references, HeatSmart Alliance, as we've got the flyers in the back. Definitely get a Mass Save home energy assessment. That opens the door to a lot of the incentives that we mentioned. And get advice from a heat pump advisor or coach. Some communities have volunteers, others have paid consulting, and I think there's some flyers in the back for both HeatSmart and Abode. Also, HeatSmart Alliance is training local groups to do coaching, and if anybody here is interested in becoming a coach, let us know. Talk to Bob. Come to the table. Get quotes from your heating cooler installers. It's good to have more than one. You'll learn from each installer and consider all the factors they put up. Next. So to contact us, we got a website, heatsmartalliance.org. Thank you.